Welcome to the second episode of this series, learning Amiga 68K Assembly with Docster. And as soon as I mentioned his name, there he is. He appeared. Hello, Docster. As I said, it is Docster because he helped me a lot in doing this preparation for the stream, or he prepared quite a bit of it. Hello, Hound Dog. And we will continue with these. I want to, oops, because I'm wearing white, the camera is not liking it. Normally I wear black, but down there, okay, down there, let's see, there are two, I don't want to say adverts because they are not. It was my decision to put them there because they helped a lot. One is Retro Passion, who has taken care of my Amigas, and he's going to take care more of what I'm going to send him. And he has been, recapping, modifying them, enhancing them, and he's very professional, but at the same time he's very friendly and he's very helpful. So yeah, he's the man for the job for me for recapping my Amigas, let's say that. The other one is practically my neighbor, it's just behind me. It's a retro shop. I just go and visit this shop, okay? I hardly ever buy anything, but he gives me things. And I'm saying hardly because I did buy things. I'm not saying I never bought anything, but he's very nice. As always, let's jump to my usual prayer. I started calling it my prayer. So maybe like this it will not vanish. Hello, old school coder. Welcome to my stream, old school coder. And remember, it was with a smile, soft, and with a please. Anyway, guys, let's start the usual. Please subscribe and like my videos. It's the only way I know how to share them, how to make them available to our Amiga community. Under each video, click there. You should find a link to the code related to that video. Okay. All code is on Mega. This is the area that I share, which is public. I have an area which is not public, which is only for my Patreons or supporters. How could say no to that smile? Good one. Please also like and follow my Facebook page. As you can see, Docster is here. Also subscribe or join the group Phase 101, and oops, I closed it, Commodore Dev, which I now closed. Let's see if it lets me to open it. History, recently closed. Yeah, there you go, it's there. And Commodore Dev. Hello, Gary. I also have a Telegram group for those that want to get in touch with me, but the right way of getting in touch with me is using Discord. Control Shift T, I was told. So if you want to send me messages on Alt F4 is not definitely not the right one. I know my shortcuts. So you can send me messages on Facebook, but normally I take time on Telegram or Discord. I reply quite fast. Let's say that. If you want to go that extra mile and support me, you can go and support us either on Patreon or on Coffee. They are identical, and as per Patreon, there are 88 things to unlock. If you become, basically it's 88 videos. So that's basically it, and we can jump to our slides. So here we are again with part 2 of learning Amiga 68000 assembly for beginners with Docster. As I said, beginners is there because of what I had named it before, but the true course is Amiga 68000 assembly with Docster. And as I said, this is pure bare metal what we will be doing. So it is the second part of the series, and today we'll get our hands dirty in a way, or your brain dirty, because you really will need to think a bit for those that have never seen certain things. So we're going to do addressing mode. Understand this right from the beginning. It's important that you understand this from the beginning. Gary, good one. Hello, Ozzy. I didn't realize you're here. So, Ozzy, what happened? Oh, I need to do something, Ozzy. Ozzy. Wait. Okay, you are back. Oh, hold on. Yeah. Okay. We did it both at the same time, and here. Okay. So I leave it up to you. That bot is mean. No. Sorry, Ozzy. So before I start, I need to cover some symbols that I have on my slides, what they mean or what they are. Well, old school coder, yes, but I don't know, 2 weeks, 3 weeks ago, somebody took advantage of my alarms and was sounding them, and I had to raise my threat level of my bot, basically. And actually, it just reminded me I didn't start something today. The Mamma Mia has not started. There you go. So, DN means any data register. AN means any address register. D60 means a displacement of minus 32768 to 32767. XN means any data or address register. And D8 means a value between minus 128 to plus 127. Notice the first two, data register, address register. There are two types of registers, okay? Data registers and address registers. Data registers can hold data, address registers can hold addresses. Let's be like that. To be honest, even data registers can have that, and they can be interchanged. But just to give you the logic behind it. Where is my mouse? Yeah. Okay. The first one, there are 14 different addressing modes. 68020 has more, but I'm just going to cover the 68,000 one, okay? First one is data register direct. That means any data register, so that's why DN. Then second one is address register direct, so that means any address register. And notice D starts for data, so data register. A starts for address register, so that's why AN. Address register indirect. So basically, whatever we have in the address register, so let's say it points to address 101, okay? Let's put it this way. It will go to address 101 and reads the value that is in address 101. That's why the bracket. Address register indirect with post increment. So basically, it does the same as the previous one, but it also increments. So 101 becomes 102 in this case. Okay? And notice the plus is after the brackets. So it increments after it reads. Predecrement. So address register indirect with predecrement. And notice also that it's a group. Address register indirect, and there are 4 of them, okay? Or 5, because there's with index. But the first 3 words are the same. It's only the last 2 or last word that makes a difference. With predecrement, it means it decrements and then reads the address. Reads the contents of the address, sorry. We're going to see examples, okay? But I'm just covering them. Address register indirect with displacement. Now, there are 2 ways how to write this, okay? The first one is with a displacement of 16 and the AN in the brackets, or the displacement and the AN in the brackets, they are both valid. The only thing I'm going to say is that one was the old way of writing it, and the other one on the right is the new way of writing it. Me, being old school, I still use the old way. That's me, however. The assemblers understand both. But just in case you see both, okay? I mean, in modern code, I think you will see, I mean, the right one, not the left one. Same thing for the next one, register indirect with index. And this one is a bit more. So actually, I'm going to go step backwards. Let's explain what it is, address register indirect with displacement. So basically, we go and get address 101, okay, with displacement. But then we have also a displacement. So let's say it is plus 10, okay? So then it will be 111, okay? The address where we're going to read. If it's byte. And that's not the right example, actually, because 111 is odd, and that means it will crash. But anyway, And it's another thing. I'm using 101, which is bad. But anyway, you got the gist. It's you add an offset to the current address. Okay, that's what it is. Remember, odd addresses crashes the 68,000. You get a guru. The last one, address register indirect with index. You have an address register, okay, plus a data or an address register, plus a displacement. When you add them all together, you get the address from where you are going to read. So same as before, but you have more. Okay. Now we have the relative. You can have a displacement with relative to the current program counter. Okay, so you can have a displacement of minus 22767 68, sorry, or plus 22768 67. Okay, so that is with when it is PC relative, so relative with offset. So from the current position, and you go backwards or forwards from where you are. Next one is the same as the previous one, but besides the program counter, you also have an address or a data register. And there's a displacement, but the displacement now is only 8 bits, not 16. Hence, minus 128 and plus 127. Now, next one, absolute short. Absolute short means it's a word, okay? So 16-bit address, which can be sign extended to 32. This might get you. Always remember that there can be a sign to a value in a register. Absolute long is an address which is 32-bit long. Immediate mode, a 16-bit or 32-bit number, and you put the hash in front of it, okay? And remember, the numbers can be binary, which are represented by a percent sign, hex with a dollar sign, or nothing, which means it's decimal. Quick mode, this you need to be careful about this one. It's also immediate number. It's a byte, but it is sign extended to 32. So be careful. I mean, quick is very short. It's a very short instruction, takes less cycles, so it's used a lot, but the 32, the sign extended thing can get you. Implied is an instruction that has no source and destination, basically, like no op. Now, all these, and there are some exceptions, but for now, think of it like this. They can be an instruction in the 68,000 has a source and destination. They can be in the source and they can be in the destination. Okay, and you will see all these used in source and destination. Okay, so that is what addressing modes are. Some instructions have source only, okay, or destination only. I better say destination, I think. And some instructions have source and destination, and implied has nothing. Okay, so that's addressing modes. And here are some examples. The first one, immediate. So move byte, and this is a hex number, 5F, comma the 0. Notice that you always need to specify the size. If you do not specify the size, then it is assumed to be a word. Okay, so .w. I recommend you to always specify the size. Always. Data register direct. So we are using data registers, and you can see that we are moving a word, hence 2 bytes. So if it was address 100, it will be 100, and well, in this case, it's data. It will be 2 numbers. Okay, I better not say any more addresses because I might confuse you. So you're moving 2 bytes from data register 2 to data register 3. Okay, so the low word of each data register. Remember, the data registers are 4 bytes or 1 or 32 bits long. Address register direct. You're moving something into an address register. Now, I'm going to mention it now, but keep in mind that address registers are always 32-bit. They are address registers, okay? Now, I am saying this to get you around the fact that address register is different than data register. However, you tell me you always need to specify .long. No, but you need to be careful. Okay, so just take it like that. I mean, you are beginner, so trying to help you out and not to confuse you. Address register indirect. So we are moving a byte. Actually, let me go back to the other one. We have moved .long, okay, D5, 2A2. We are moving 4 bytes. So the 4 bytes that there are in D5, okay, because it's a long word, into address register A2. Okay, the previous one, okay, we were moving 2 bytes from D2 to D3. Address register indirect, we are moving 1 byte, okay, 1 byte from whatever the address is, okay. It is a 32-bit address, okay, so addresses, you need to think of them like that, into D3. So byte pointed at by 80, copy it into, that should not be D7, but D3. I'll take a note of that. I have a mistake there. Yeah, thank you, Oscar Coder, but I saw your message now, but yeah, you are right. Short form, but you should know what it means. Address register indirect post increment. We are moving a word pointed to by the 32-bit address, which is held in A5. Okay, so notice every time there's an A address register, I'm saying 32-bit address. Okay, that is in A5. Okay, we move it into D2, and whatever is in A5, the address that is in A5, the 32-bit address that is incremented by 2 because it is .word. address register indirect pre-decrement. Okay, we are moving a byte at this time from the 32-bit address A2, okay, -1. So example, yeah, which one? At example line 5, 1, 2, 3, 4, 5. Yeah. Yes, it happens after. Hold on, that was word though. So no, it will be incremented by 2. So it will not be. Now this is where I'm avoiding mentioning address registers. You gave an odd address. That address should be 1 to 2, so that it can be incremented to 1 to 4. You have to be very careful with odd addresses. But yes, it happens after. I'm trying to avoid saying numbers of addresses, because you tell me, how can you address an odd address? Well, you can, but you have to be careful. The instructions needs to be in a certain way and all that stuff. So you'll get used to it. So add register indirect pre-decrement is the same as the post increment, but the subtraction happens before you actually read. Okay, so if it was 1 to 2, because it is a dot byte, it becomes 1 to 1 and reads what is in that address into the 4. Oh, Hydro, really? So we continue. Now I'm not there. I said there are 14 addressing modes. I'm not going to give all 14. I think I'm giving 11. Okay. PC relative. I am, because you need to see it. PC relative. To be honest, that I've skipped those. And implied. So address register indirect with displacement. So you move what is in 80, the 32-bit address in 80 plus 101. Okay, you use 2, because it's a word, you use 2 bytes and you move them into the 0. Same thing, address register indirect with index. So basically, and I'm showing it here, is the same as the previous one, but we add everything together. So, and notice that the first one, remember I said it's only 8-bit. Okay, so we can only have from 0 to 255. Okay, the displacement actually from -1 to 8 to +1 to 7. The 80 is a 32-bit address. And you add, but only 16-bit, not 32-bit value that is in D1. So that's why D1 has got .w in it. Okay? So this trick of using AM plus is like a built-in. Yeah, they are all counters. The 68,000 is very good at counting, at having counters. These addressing modes are all counters. Absolute short, as I said, be careful of this. There's an address, okay, 9880. We are moving that because this is sign extended. So notice what happens. It's not 9880, okay, but we are FF9880. You have to be very careful about this mode. If it was less than 8000, then it would be the actual address. But because it's higher, then it becomes sign extended. So FF at the front. And remember, the 68,000 is 24-bit, not 32-bit, the address bus. So I could have written it as FF, but actually it is FF9880. However, in your mind, start thinking about FF. Okay, here is just to make it clear. Because when you go on the 68,000 on the 68020, it's like that. Absolute long. Notice I have a long address, and we are copying a byte into D4. Only each register has got 4 bytes. No, only one is affected. Whatever value there was in the other 3 bytes remain as it is. Okay, so sometimes or many times you need to clear the register. Quick mode, you will use this mode quite a lot because for small numbers, but remember it is sign extended. In this case, we are moving to C in D3. I will go into more detail about this sign extended part, but don't let it get you, okay? And not today I will go, because sign extended part is way ahead. But keep in mind, and you're good to know it. So, creating assembler code. Now, I use Vazim, I use Azim Pro, I used to use DefPack, and I used to use Azim 1. In the old days, I used DefPack. Well, I used Azim 1, and then I switched to DefPack. In this era, I use Vazim a lot, but I also use Azim Pro. And so on the Amiga, I run Azim Pro. Vazim is not on the Amiga. I mean, technically speaking now, okay? But you run it using Visual Code, okay? However, Vazim is DefPack and Azim Pro compatible, but there are some exceptions, okay? Which are minor, but people, I think, forget, or I don't know. However, Vazim is more DefPack compatible than Azim Pro, okay? So it is more, even have an option to be fully compatible with DefPack. Just to give you some hints before we start. So each instruction is written, or each line of code is written as I have at the top. Label. In my case, I always do label by its own and then jump to the next line, but label instruction dot size. Okay, remember that dot size. Source destination, comment. And comment, now I use this semicolon, okay? In theory, okay, you do not need to use a semicolon. You do not need to use anything, okay? Just a space, and that's the comment, because you are into the fourth column, okay? The assembler will know, but this is not supported by all assemblers, so put the semicolon. Size matters. So prefixes, you already know this. Percent is binary, dollar is hex, hash is immediate. Specifying the size. Instruction dot B means byte. Instruction dot W means word. This is a copy and paste, so I have mistakes there. Nobody noticed this, but that should be byte, word, and long word. So I have mistakes there. If you know how many times I saw my own slides and this escaped. I cannot believe it. Too scared to say, ah, that's what she said, no? So dot W is for word and dot L is for long word. Indirect addressing is always with the brackets, okay, that we know. In expressions, and here I'm going to emphasize this because assemblers are different, okay? In expressions, use always the open and close brackets, not the square brackets. You will fail. ASM2 supports the square brackets. Do not use the square brackets because it will not assemble in other assemblers. Use only the normal braces. Assembler examples. So some examples here. We will see a lot of examples, or I'll cover quite a bit. And notice I'm using the move instruction. The move instruction is load accumulator and store. So LDA and STA, it does both. Okay, so that's why there is no LDA and STA, but move, because from source to destination. For those that are 6502. So move.byte blasphemy. Move.byte, notice immediate hex, okay, and it's a F5, D1, okay, storing, so store immediate value, so the hash, the hex, okay, and it's a byte. And there I have another mistake. The hex should be dollar. F5 into register D1. Notice I set 8-bit transfer, so the other bytes in D1 are not changed. Okay, so if there was something else and then you later on you read move.long, whatever there is in D1 to somewhere else, you have the wrong value. Okay, and you'll do this. Okay, so be careful. Move.word, what is in the 32-bit address into the 1. Okay, that means store the contents of memory address by A2 into the 1. This is 16 bits, so 2 bytes. Whatever is in the high word of D1 remains unchanged. Yes, I'm very confident you'll do all these mistakes because I still do them. And everybody does these. Another instruction that you are familiar with is the add instruction. We are adding along the value of D4 with D5. Now, remember, source, destination. So you're adding whatever is in D4, whatever is in D5, and stored in D5, because D5 is the destination. So add the 32-bit value in register D4 to that of register D5 and store the result in D5. 32-bit value addition. Because it's an addition, the flags will be set accordingly. So that was just to give you a small premiere of the 68,000 assembly. We're going to see the instruction set. Now, this, what you're going to see now, is mine. I did not have enough info. I better say not, it's because it was not a question of time, enough info about this 100%. But I grouped them to best of my knowledge. And I said what is for beginner and not. And also I indicate which is 68,000 and which is 68020. Okay? It is my own table. I'm not saying it's perfect. And if somebody finds mistakes, please tell me. So, data transfer. So these are the instructions that I think, okay, so it's my grouping here because I couldn't really find this type of information. Data transfer instructions. Now, notice the columns. The first one is the instruction. Second one is the CPU. Okay, if it's blank means it's 68,000 and above. But if it has 68020, it means only specific to 68020 and above. Okay, just to give you an example. Assembler short form. When you coding, okay, you do not need to give the assembler move A, move M. You can just do move. The assembler will know. We can distinguish between move A, and move M. So the assembler will help you. Then there is the meaning, and the last column is, in my opinion, what you as beginners should know as instructions. So, move by its own means move data. So move data, so data register. Okay. Move A means that you have a address register. Move M means you have multiple registers. Yes, the 68,000, you can specify a range of registers, not just one, as source or as destination. Move P is used for peripheral devices, so you will actually that's a mistake. You should move P should not really shouldn't really bother you. It's not for beginners. Move quick, we covered it. You need, so the assembler, if you do a small number, will convert it to move quick. But I suggest you specify always move quick. The reason why is if the assembler converts it into a move quick, you do not know. So the others, move A or move M, okay, it's fine, you do not. But move quick, I suggest you always write it. So that's why I didn't include it there. But it can convert it, okay? It can optimize it to move quick. An instruction can be changed. The assembler can optimize it to be move quick. LEA, load effective address. I will explain all this, but it's a physical address. This is the only instruction that pushes an address to the stack. There isn't any more push instructions. And people are already scratching their head. How does it use this stack? But I will come back to that. Swap. Okay, swap the register half. It means low byte becomes high byte becomes low byte. Exchange, it exchanges to registers, so it swaps to registers. Link and unlink, I will leave them for when you scratched your head a bit more. So I'm not going to cover all the instructions, but I'm just telling you about them. The add instruction. So if you type add on its own, it can be add A, and add I. The difference between them is one is add data, the other one is add address, and the other one is add immediate. Okay? Add X means the extended bit. You do not worry about it yet. Okay? Add quick, do it. Okay? Do not let the assembler do add quick. The next two are 68020, which I won't cover, but you might see them, so I mentioned them because my table is for Amiga, which is 68000 or 68020. Clear is to clear register. Okay, compare is to compare, and notice compare, there are various ones. Compare address, compare immediate, and compare memory. If you type compare, it's enough. Okay, the 68020 has also compare to, which you can specify bounds, but that's for another time. Division signed. This is for division of signed numbers, and then there is division signed long in 68020, but for now we are going to deal with the 68000. Then there is division unsigned and division unsigned long, which is also for the 68020. This group, as I said, group 2, arithmetic group, and this group is quite long. EXT is for extending the sign, which for now you don't need to know. And then there is multiply signed and multiply unsigned. Okay, then negate to change the number, and negate text to make the number negative, basically. But negate text is with the extended. For now, you don't need to worry about it. Same for, like I said, for add, there is for sub. Okay, you know these instructions because they exist in 6502. Okay, so you know them. You type sub, but actually, depending what address registers you are using or data registers you are using, it turns into one of these. The assembler does it behind the scenes. So sub A, sub I for immediate, and sub quick, I encourage you to write it again. Sub X is for the extended bit, so you don't need to worry yet. And then there is TAS, which is test and set, and TST for test. To be honest, these two should be in the test logic. I should move them. I get another piece of paper. Okay. Logical group. Okay, there is and I. You can type and it's logical and immediate. I mean, you can use it for immediate, and that's why I. Or is the same, or and or I, logical or immediate with a value. XOR, exclusive or, the same thing. There is exclusive or and exclusive or immediate and not. So logical complement, and notice they are all beginners. You should know these. These are the favorite of Docster, shift and rotate group. Arithmetic shift left and arithmetic shift right. I mean, they are in the 6502. Logical shift left, logical shift right. Rotate left and rotate right. And then there is, with the extended bit, arrow XL and arrow XR uses the extended bit. You do not need to worry about those, but know that sometimes you will, if you are shifting bits which are from 32-bit to 64, you know, if you're using two long words, you might need the extended bit. Bit manipulation. This is where I should have put TST and BST, but the 68,000 is rich in a way, and the 6802 is even more richer in bit manipulation. Okay, so you can change a bit, you can clear a bit, the first two. I'm not going to explain the 68020, and then you can bit set and bit test. Okay, I wish these existed in the 6502. Binary coded decimal, for me, maybe use them in the 6502. In 68,000 I wouldn't bother, but in fact I didn't do them for beginners. You don't really need to, but there is add binary coded decimal with extended, negate binary coded decimal, and subtract binary coded decimal. The other are 68020. Yes, a lot. Okay, now program control. Notice I have instructions with CC. That means conditional group. Okay, this is where the 68,000 is very rich, very rich. Okay, the 6502 dreams of this. So the first one is branch. So there's a condition and you branch. You tell me, where's the, wait till I explain what CC means. Call M is for the 68020, and it's for calling a module, which we will not cover. Decrement and branch according to the conditional code registers, conditional codes, sorry, which means decrement a value in a register, and when it reaches, when a certain flag is set, depending on what you are trying to do, then stop branching. Okay, and the other one is conditional set, which is also set based on the conditional codes. Branch is like jump, but there's a difference which you will encounter later on, because it's related to sections. So Branch is like jump, but branch can only jump into a certain, within a certain block, let's say that. And branch to subroutine can also jump within a certain block. Jump is as you know it in the 6502, and jump to subroutine is as you know it in the 6502. However, jump and jump to subroutine are very, very cycle. They use a lot of cycles. Branch and branch to subroutine use a lot less. They are faster, but you are limited of where your jump can be. Okay? This has to do with sections, and I will cover sections later on. RTD is return and deallocate parameters, which I'm not going to cover. RTM is a 68020 return from module, so the same is when you have a call. And RTS, which you know, is return from subroutine. Please remember that CC, okay? I will come back to it in a moment. System control group. These are instructions that, let's say, control the CPU. Let's say that for now. And immediate with the status register. As you notice, they are all advanced. Okay, so I'm just going to go through them. Maybe some of you have heard of them because of the 6502, but it has a lot more. Okay, breakpoint, you know what it is. It's creating a breakpoint. Check register against bounds. It is an advanced feature. And then there is the check to on the 6820, which is also check register against bounds, but with more options. XOR immediate to the SRF, to the status register, and move to the status register. Illegal, this is where you can create traps. So say illegal, I don't know, something, and it creates, and it jumps to one of the traps. The 68000 has got traps where you can tell the CPU to jump to a certain trap. You program these traps and it does certain things. Interrupts on the Amiga use traps. They are vectors, but yeah, let's say traps. Not to confuse you, and then there's the trap instruction. Trap, and notice CC. I did not highlight the CC here because it's a 68020, but also traps on a condition. Okay, conditional code. Trap V, traps on overflow, and I, CCR, and immediate to conditional code register, or I, immediate to conditional code register. XOR, same thing, but on XOR. Move CCR, move to and from CCR. RTR, return and restore conditions, and no operation. Many of these are used. No, interrupts are not traps. That's why but they are used by interrupts, but they are not traps. Different story. But yes, and to be honest, what is called a trap, because this is a generic name, trap, it's what is called vector. Okay, in Amiga terms, it's a vector, not a trap. But it depends on the machine. In Apple, it's a trap. Okay, just to give the difference. It depends on the OS and how they programmed it. These are the instructions that you will not use unless you use interrupts. And these instructions are when you switch the CPU into supervisor mode. They are very advanced. and one needs to understand quite a bit to use these instructions. Move C is move the control register. It's a 68020. To be honest, it's a 68010 also, but I am not including the 68010. Move S, move address space. RTE is when you jump. So you have an interrupt, and you do not use RTS when you have an interrupt, but you use an RTE. Okay, return from exception. And notice the word exception. Traps are exceptions. Vectors are exceptions. So you return from an exception. Move SR, move to and from, so this is both ways, from the status register. Move USB, user stack pointer. Yeah, just know that it exists. Or SR, or immediate to the status register, reset, of course, uses the processor, and stops the processor, or halts the processor. The 68020 have more instructions. This is if it has a coprocessor, and basically it is to, let's say it has a 68882 coprocessor, so it's the METS coprocessor, and this is how it talks to the METS coprocessor by using these instructions. I'm mentioning them because the Amiga A1200 on the motherboard can have a METS coprocessor like what I have, and this is how you communicate with the METS coprocessor. Now, I told you that CC means something, and this is the list of conditional codes. So, branch on true, branch on false, branch on high, branch on low or same, okay? Branch on carry clear, branch on carry set. Imagine the letter B at the front, okay? Branch on not equal, branch on equal, branch on overflow clear, branch on overflow set, branch on plus, branch on minus, branch on greater than or equal, branch on less than, branch on greater than, branch on less than, and equal. Does that explain how rich it is? So, in front, you have either the letter B, okay, so branch, or DB, which means decrement, so decrement some data register, and branch. Yeah, branch on biscuits. And guys, all beginners, you really need to know this. So, this some facts, and the sentence that there is under is while I was listening to OSK. Instead of, hey, pay attention to chat, hey, pay attention to the slides. Exactly. That's where I got it. And because what I'm going to say now can catch you. Fact 1. Address register A7, you know this, is used to point to the stack. We all agreed on that. There are no push or pop instructions except for PEA, okay? Push effective address. Now, there are push and pop, but not as you know them. They are with the move instruction, okay? The move instruction, the one that follows move.long did 0, comma, minus A7, okay? So wherever the stack pointer is, and it's a minus. The minus means decrement and then put the value. The stack is on top of memory and goes towards the 0. So if the memory is at FF, okay, remember it's 24-bit, it goes towards address 0. What happens really is, okay, and guys, follow this, because after this slide, you're going to realize that there is more to it. So understand it. It decrements a 7 by 4 and writes the 32-bit address or value, sorry, to the stack. I hope this is clear. So it decrements by 4. It's move.long, okay? But what really happens is this. It decrements a 7 by 2, writes the low word of the 0, decrements a 7 by 2, write the high word of the 0. Why does this happen? Because it's a 16-bit machine, not like the 68020. So the data bus is 16-bit, so it cannot write 4 bytes. It writes at 16. Hence, it's costly. A pop is done by the stack pointer, but this time is plus, so we are incrementing. So we read and then increment by 4, and we move whatever we have into the 0. And as I said, stack grows downwards towards lower addresses. We are doing 68,000 assembly programming. This is the second episode, so I don't know if you're familiar with it or not, but say hello and let us know. Nobody's going to, say anything if you don't know anything. You can learn. As OSK says, nobody's going to bite you. So, push effective address. So, we are putting on the stack whatever is in register A4, the 32-bit address, plus 20 hex, which is 32, to the stack. So effective address is A4 plus 30 plus 20. Result is pushed, of course. So the move instruction is very important in the 68,000, and that's how you do push and pop. Branch to subroutine and jump to subroutine. Both of them call subroutines. Both of them push the program counter and branch. But JSR, costly, but it can address all address memory. I think you do not know what you're doing. The processor knows very well what it's doing. Jump to subroutine, it can execute code from different sections, and this you will see when we describe sections. Branch to subroutine can only do relative to the program counter. It's less cycles and faster. Hence faster. Branch to subroutine works within same section code. Okay? Of course, RTS pops program counter and returns to the next instruction from where we left, basically. I think I have taken more time than I thought. Okay, so this is where you get your hands dirty. These links will be available on my Discord, but I'm going to, oops, one backwards. Did I close it? I think I did. Okay. Can you see my screen? Okay, so I was hoping I will be able to, it's not letting me. Them, so I have to do this to be able to share it with you guys. So the first two, when you want to learn what an instruction does and want to test an instruction, I suggest you use one of these two. We will cover them in the next episode, but for now, I'm giving you the links and you will, we will go through them. But if you want to start downloading, you can download them. Here is Assembly Pro, which we will need on the Amiga. Here is the emulator, FSUAE. Guys, I know that last time I said I prefer WinUAE than FSUAE, but those that are on Linux or Windows, or Mac, they have no other choice. So I will also cover this. And here is WinUAE. We will need Workbench for the Amiga. So we will need this one. And we will need to enhance the Workbench. So you will need this one too. Now, this one, unfortunately, just for me to be on the safe side, since I am streaming this, the ROMs of the Amiga, you can get them from the Play Store, okay? I think they are like $2 or £2, I can't remember exactly. And you can get them from there by buying them, and you download them on your Android phone and then copy them to your PC. Okay, it's the cheapest way of getting them. Please note that I'm not going to make, I do not want to be responsible for this, okay? Some people are complaining about this thing. Sometimes it doesn't work. So if you cannot find the ROMs, then if this thing doesn't work, then you need to search the internet to find the ROMs, okay? When I gave you the link of the Workbench 3.1, if you search there, you should find them. You can buy Amiga Forever, but it costs more, while Play Store, the Google Play Store, it's only £2. We will also use the Amiga extension on PC, or you can use it on Linux. It works PC on Linux. We will need Visual Code and the extension. These last two, we will use them on Windows or Linux. You can use them Windows, Linux, or Mac. On Windows, you have the selection of WinUAE or FSUAE. On Linux, you have FSUAE only, but the extension works. Last but not least, is my page, which I have updated again. It has these links also in it, and it has information for you to get you started. I had already shared this. Ozzy, I know you use it because you are crazy on Linux, but I am crazy on Windows. Let's say that, because FSCUAE gave me too many problems in the past. I know it is growing, I know it is better, but these are beginners. So I just want to make it clear to them that some results might be different between FSUAE and WinUAE. Yes, you are. But anyway, it doesn't matter. I'm pulling your leg, you know. I'm too poor to buy Macs. Good one, good one. And you're too poor to buy Windows too, I assume. Good one, Ozzy, good one. Good one. So yeah, guys, I will be going through these next. Oh, I forgot to say one thing. Probably next week I will stream, but it will not be an Amiga stream. I think I need to do an RPI stream next Sunday. I need to check with Emanuele, but I believe I have an RPI stream on Sunday. So last link broken. Did I put a space in it? Because it's very picky. If you do this book page, I think it gives you the link. There you go. You can use that. So we have arrived. Give me a second. Today I should. Listen. Hey, listen. What happened? Yes. Yes, but we are using more than one assembler. So, but actually, Vazim is the right one. I mean, I will be using Vazim. You will have to, if you're trying to load everything, just wait till I cover the visual code with the extension, okay? Because you will be confused, or you can get confused. I gave you the links so you can start looking at, but I do not want to cover Vazim or Azim Pro right now yet. So uh, let's see if it will work, this one, because I am confused. Give me a second. Which one should I get? Man, what? The Do not try to get Vesim. The extension will get you the right Vesim for you. Do not try to get Vesim, okay? The extension will do the job for you. Because I'm going to Vesim, it's you need to understand the different types of Vesim that there are also. Save. Why it is not starting? Of Hound Dog is third, of course. Master Yoda second, and of course the master himself, Old School Coder, wins the second round for the second time. Come on, guys, beat Old School Coder. He's having fun here. Yeah, 2 of 2. So, guys, we came to the end of the stream. I'm going to raid, as always, Amiga Bill. Thank you very much for participating. As I said, next Sunday, I am not sure I will be able to stream this series. I think I have to stream RPI because of the car racing game jam. So I think it is next Sunday. We will continue with the setup of the tools that we need to do assembly on the Amiga. Next one, it will be less slides and lots of hands-on, basically. Thank you very much. Hope you have a lovely evening. On Tuesday, we should have Ozzy back on the stream. And we continue with his car game. See you guys. Bye-bye.